And good afternoon to all of you, and welcome to the Smart Grid Educational Series webinar for November 2014. This is Irfan Ibrahim, your moderator, and today I have the privilege of bringing William Miller, who will be talking about the XMPP protocol and how it relates with the Internet of Things. So before we get into that presentation, let me put this presentation in context. As you know, through advertising on television and in many of our industry conferences, this concept of the Internet of Things is being tossed around. But not too many people really understand what that would entail in terms of interoperability. Because in the past, if you look at the evolution of networking, we started out with mainframe computers and dedicated dumb terminals connected by wire, and there were very specific commands that went back and forth between the dumb terminal and the mainframe. Then we moved into the packetized way of doing networking, and we got into routing and switching, and in that, we had a middle layer called the IP layer, and then above that we would put the transport control protocol or the user datagram protocol, and that would provide us activity across multi-hop networks. But the application layer still needed specifications on the format and the file sizes and things like that. So data was being moved on this networked or multi-network system. But now when we are talking about devices, now we're talking about appliances, computers, a heterogeneous group of smart devices that exist in society. And if we want to network all of that, we can't just simply use the network protocol that we were using for just linking computers. As you know, the different devices have different attributes, and they will respond to different types of commands. So it was necessary to put in the application layer of the OSI model certain messages, certain commands, and also certain object models that would then speak to this heterogeneous group of devices. And XMPP is one such attempt to standardize that application layer so that we could have a variety of devices literally auto-negotiate, connect, and start messaging back and forth and start taking commands from some central console. This is very, very important because if this does not happen, we're going to be stuck in silos of vendors who are going to create their own little ecospaces. And you're not going to get the rapid adoption and deep penetration into the society of these devices. You're just going to end up with little fiefdoms of large market players who are just going to create their own environment. So XMPP is an attempt to separate by making it technology and protocol agnostic. It allows you to have a standardized model for controlling a variety of devices. So all devices vendors have to do is be compliant to this standard, and then they'll be able to interoperate. So this allows the different vendors to remain competitive based on the characteristics that they're bringing in their devices, but at the same time, maintaining a certain level of standard protocol for data exchange and messaging so that they can all coexist in a heterogeneous community. So with that background, what I'm going to do now is ask William to join us and talk a little bit about the XMPP protocol, what advances have occurred since the past year that he has been working at this within his working group, and also to talk a little bit about how this relates to smart grid and the Internet of Things. So with that, I'm going to move the presenter ball to William. And The ball is in your court, and all you have to do is, if you see the two horizontal arrows at the top of the slide, you can use that to move back and forth, and it's all yours, William.
Okay, I was looking for those arrows. You say it's the upper part of the screen?
Yeah, in the middle of the screen at the top, there are two horizontal arrows, and that allows you to move from one slide to the next.
All right, I think I see them here. Okay, well, good afternoon, everyone, and thank you once again, Irfan, for allowing me to provide an update to the group on the activities that transpired in 2014. And let me just kind of move forward.
Okay, I don't see you moving the slide. Do you see those two little arrows in the middle of the top of the screen?
Yeah, I was pressing them here, but they're not doing anything.
Yeah, you just have to go to the arrow and then press next. It says next page, and then you can click on next page. If it's a problem, I can take the presenter ball and do it for you.
Trying it again. Yeah, you may have to. I'm pressing the button, but it's not doing anything.
Okay, no problem. I'll move the presenter ball back to myself.
Thank you.
And I will move to the next slide. There we go.
Okay. Well, I'm going to just cover the agenda here, and I guess I'll have to rely on Irfan to push the button for me. And we'll kind of cover a little bit about what is the Internet of Things, as well as a bit about the standard, which is called P21451-1-4, that we more affectionately call it Sensei IoT. And then I'm going to touch base on something new here on software-defined smart grid, and give you guys a little bit of an update on an activity that we had this year called Smart America Challenge, and a new activity for 2015, which is called the Global City Team Challenge. Let's move to the next slide. Okay, everybody's been seeing the Internet of Things begin to be talked about in the Internet community. And if you'd move forward again, Irfan. But as you've probably noted, the Internet of Things is evolving out of the huge growth in social networking. And of course, that's kind of driving all the innovation of the Internet right now. Go ahead and moving forward. And I wanted to bring everything into perspective for everyone. You'll be able to look at these slides quite a bit more after the presentation. But you know, we're seeing an evolution of the Internet from almost 30, 40 years ago to now we're in the middle, more or less, of what's called Web 2.0. And we're moving, you know, transitionally into what we're calling Web 3.0, which will be the Semantic Web, the use of semantics to better control the Internet. And this is going to be very important because as we move to Web 4.0, which is where we would have more integrated intelligence into the Internet, which is called 4.0, the intelligent web. I think we'll finally see that come about in the next, you know, 4 to 5 years. Next slide. I'm providing this update on the mind map that we had. Some of these slides we did show last year, but I imagine there's a number of people on the call who did not attend last year. But this mind map is growing every day, it seems, because new applications are you know, coming about. Next slide. I grabbed this particular diagram because I was particularly impressed that what we are showing is that emergence of the Internet of Things. And of course, right now, there's been a lot of terms related to what people call Internet of Things. I mean, you're hearing it in the industrial community as the industrial Internet. You're hearing some people calling Internet of Everything, if you happen to be from Cisco. Internet of Things, though, is, in fact, as Irfan pointed out earlier, integration of various devices that we might have, in our homes, our buildings, in our cars, and that we'll have those things interact with us. But that's just been happening in literally the last 5 years with the explosion of the use of smart grid, smart devices. And of course, we would like to use those with smart grid. Next slide. I wanted to put this diagram up again so you can kind of take a look at what has been the expected latencies that you can see on the left-hand side. And of course, we've been trying to achieve as fast communication as possible, using the same device-to-device type capabilities that we've had in a lot of automation systems today. But again, most of those have been wired, and we have had new wireless systems which are, broadband. But of course, we can tolerate even longer latencies for a lot of applications. So it would be very possible that we can do some things like even use lower radio frequencies, which we have used in the past, but in new dynamic ways. And next slide. I did want to point out some of the protocols, which I can imagine a number of you on the call have heard these protocols, but probably I'm not going to go into a lot of detail of all of them, but I wanted to show you where the standards work has been going on at the moment. And as you can see, XMPP, which is the Extensible Message and Presence Protocol, which has been around since, I guess, the late 1990s, when it was called the Jobber, developed by the Jobber Foundation, and it's now called the XMPP Standards Foundation. But it's now recognized, within the IETF, W3C, and now within ISO, IEC, IEEE, and most recently the UPnP Foundation has picked up on it. But other protocols that are being used and have been recently standardized is like MQTT, message queuing and telemetry transport. The OASIS Foundation has recently taken that on as a standard. Of course, you might be familiar with RESTful state transfer, which is called REST, which has been put forward by W3C. And of course, Constrained Applications Protocol, another standard that was developed by the IETF. Next slide. But I wanted to kind of show you this picture here, which you can look at. You'll see there's quite an ecosystem of systems that have been out there already, a lot of them in the social network area, as well as present systems like the one we're using right now, like WebEx. WebEx, GoToMeeting, and others utilize XMPP to set up their security session. And of course, social networks like Skype, Yahoo and others, again, they've used that to set up their security sessions. But one of the things I'll talk about a little later is not everybody's been aware of that the area of software-defined networks has also been using XMPP. And a number of other protocols that have been discussed in standards groups have now been integrated into industrial automation, like IFMAP, which I won't go into a lot of detail. But again, XMPP is that protocol that they've all been adopting to set up their security sessions. Next slide. I'm just going to give you a quick background of where we've been, because we started this effort back in 2013. And of course, we're approaching 2015, where we're trying to add the final elements to the draft. But already products are beginning to take shape and enter the market. Next slide. And for those people unfamiliar with what the standard is, which you can also check out our website, which is sensei-iot.org. But it's hosted by Dr. Kang Lee, who is chairman of IEEE TC9 Sensor Technology, and a new chairman from ISO JTC1 ST31, Dan Kimball. Our previous chair from ISO Craig Harmon, unfortunately, he had passed away this past July, but and we do miss his participation and his vision. They have been participating in the automatic identification of the Internet of Things, which I'll talk about in just a second, which is a very important element. Next slide. And the Universal Unified Identifier, which has been submitted from ISO, I apologize, there was some spacing here, which PowerPoint decided to add in, but it's making use of what's called a Java identifier, or a JID. And today we're seeing that take the form of what is called a QR code. QR codes were developed by the Japanese for their auto industry, but it's been starting to take hold in many other areas. And in this case, incorporation of the number of identifications that have been developed over the years, which literally is hundreds and hundreds of identification schemas from manufacturing to shipping and so on, have all evolved. But trying to have those have a way where they could still continue and share whatever information for the things that they have has been quite a challenge. So Craig Harmon previously set out that good work in TC 122 and from JTC 1, and then now Dan is carrying it forward from SC 31 Working Group 2. And their Working Group 4 is handling the Internet of Things. But you can see in the middle what the structure is, which more or less looks like a URL that you would have put together in an email. Move forward. Next slide. Well, I've also added some new members to our group and expanded what we've been doing over the last year. We now have a subgroup in China, which is chaired by Dr. Sun Wu from the Shanghai Jiao Tong University. We also have one that's being started by Dr. Hassam Gabar at the University of Ontario Institute of Technology. And I'm continuing to host our activities here, which we call our main meeting for the US, South America, and Europe. Next slide. These are the extensions that we've been working on in our standard to the XMPP protocol. The ones that are indicated by XEP 000 are still pending within the XSF, but we're expecting that we'll have our number on that pretty soon. But I'm going to talk a little bit about these in the course of this presentation to kind of give you a little bit of an idea of how you can construct your own sensor system. And we do have a new SDK, software development kit, and Android app that's available. So I'll be telling you more about that later as to how you can get access to that. Next slide. Just a quick background on the 21451 Smart Transducer Standard. Next slide. Because we're riding on top of that standard. It's been around since, again, the late 1990s, and it's been the only smart transducer standard. But it has taken a lot of different shapes over the years. But it had qualities that I found very interesting, and extending that through the work that Dr. Pang Lee has done at NIST because of its ability to have self-identification, self-calibration, being time-aware, location-aware, have intelligence in the signal processing built right into the sensor, of course, ease of measurement, and standards-based type wired or wireless types of communications were addressed, and enabling a connection to other systems, to try and make that plug-and-play capability. Next slide. And this is kind of the overview of the 1451 standard, which is now called 21451. Recently, ISO has now added the 2 in the front to a lot of the IEEE standards numbers. But the original architecture that you see here, which was called a NCAP and a TIM, was used to develop the basic sensor interfaces of the 1451 standard. But by adding XMPP, we're now able to add connectivity to the Internet with built-in security, which is something that the original sensor left to others. The sensor standard 1451 really didn't have security built right into it. and relied upon someone to provide a layered on kind of security. Next slide. And of course, there are literally thousands of vendors out there who not everybody's aware of that make use of the 1451 standard, which at the center of it has been what's called the transducer electronic data sheet. And it basically was an XML type of package that would go into a chip that was put into various types of sensor devices. And in some industries, the aircraft industry, for example, Boeing has that. There's a number of manufacturers in the Netherlands and Denmark, for example, who have the TEDs built into all their machinery. I was rather surprised as I learned more about this particular standard, which is called the 21451-4, just how widely used it was. This was a first attempt to gain that interoperability that Irfan mentioned earlier. Next slide. But our 21451-1-4 standard is now concentrating on defining the request and replies, which is the messaging in the XMPP protocol between a requester and a replier, if you will. Next slide. And of course, we define an XMPP interface, which will allow you to build that in with a service bus that may be built into a gateway, or you may have the I/O subsystem connected directly to the internet, possibly in an embedded device, or providing server-to-server types of communications. So the sensor and actuator then are isolated by the message channel, which I'll talk to you about in a second. And as I mentioned earlier, XMPP is a technology agnostic and protocol independent system. Next slide. If everyone is not aware, XMPP was, of course, developed from the Jabber Foundation, now called the XMPP Standards Foundation, or XSF, and they have to be consulted before you can submit those extensions into the XMPP protocol, which appear in many of the operating systems today, as well as browsers. Not everybody is aware that it's there. I would rather be surprised that even many of you who are using social networks today and other systems probably were unaware that XMPP was that key protocol that was enabling the security of those systems. Next slide. And I just wanted to point out that there's been a number of RFCs within the IETF, which you can look at here later, and that discusses the XMPP protocol. I did try and provide some links at the bottom of the slide, so later on, if you download the presentation from the website, you'll be able to just click in right away and not have to do much searching. Next slide. And once again, we're describing a cloud-oriented type, service-oriented architecture that I'll cover these 3 points just so you're better aware. Next slide. Okay, what we have in our message router, because an XMPP server is in fact an applications layer router, which it's passing messages, basically, and it uses the unique identification that I spoke about earlier, and you can at that point apply policy on the particular flow of information. And of course, the messages themselves are not retained in the XMPP server. They're basically routed to the endpoint. Probably one of the most important elements that we haven't seen is that idea of presence, such that we can know that the end device is actually available and online, so that we can access that information. Next slide. And of course, the key element in the middle that's is just called the service broker, and it's responsible for directing the flows between the multiple endpoints. Next slide. And of course, the message channel, can be shared with all the various trusted users and devices and applications that you may want to connect. And they can reside in different domains. And that's going to be an important element for the Internet of Things, because we want to be able to possibly share information from the power grid with first responders, for example. Or there may be some other domain where things from a home for healthcare systems. Again, these things reside in different domains today, and as Irfan pointed out earlier, a lot of these have become very verticalized. You have to get a different app, you have to have different systems, and of course each one can't generally share information easily. But what we wanted to achieve is to come up with a common language so that we could facilitate this exchange of sensor data. Next slide. This is a really important slide. There's a lot of detail here, but one of the things that we worked on this past year was the IoT provisioning. And this is an important element because what we want to be able to do is be able to get our thing, if you will, a device or whatever, and we want to be able to register it with a XMPP service, and then whenever we want to use that information, we just share it. So if you've used like a social network today, it's probably the best reference I can think of, where you would have possibly had a friend who wanted to talk to you, or you wanted to invite a friend. You had to give them permission to be able to talk with you, whether it was voice or video or data. Well, now you'll be able to do such things with sensors. And the most important element is this idea of mutual trust, and that whenever you have registered your device, you as the owner must come back and claim that device. And then you will have to decide, well, who am I going to share that information with? And that's a very important element, which whenever you do this in a more centralized fashion, you don't really have the control of what that is. We'll cover a little bit more of that as we go by. Next slide, please. Okay, I just pointed out this idea of data sharing, which is a very important element. And the various resources that are at the endpoints, which may be from an application or a device, you want to be able to provide access to that information. Well, now you can designate that capability through the provisioning of your system. But we'll be using metadata in the form of XMPP, which will offer a degree of metadata isolation now, where that metadata is encrypted, as well as the device provisioning, and the use of the service broker provides isolation of the actual protocols you're going to transport. And as was mentioned earlier, we can actually transport other types of protocols. So even though, as I showed you earlier, there's a number of Internet of Things protocols, not all of which can still communicate with legacy applications. And that's something that's very important, because we're not going to really get rid of a lot of those existing systems that are using Modbus, DNP3, 61850, and many things, Profinet. We want to be able to share information from those systems. And we wanted to obviously have that degree of trust that we can do that. And that's been very difficult. Whenever we have that information shared to a centralized server, there's been issues now of confidentiality concerns. Is someone going to exploit that information that is coming from your sensors? And we probably see that today in the sense that whenever we're cruising the internet, a lot of this information is being collected, and using data analytics, they can possibly look for certain patterns of that information. So again, this is a big concern when we think of critical infrastructure. Do we want just anybody being able to do that, let alone your own personal devices? And I guess I wanted to bring that into clarity because, for example, in Europe and outside the US, they are strongly against that kind of more centralized collection of information, but they don't have a problem if the end user authorizes that information. So there's a little bit different thinking going on there. Next slide. I wanted to just show you the elements that you've probably been hearing a lot about, which will address scalability. As you can see on the left, our traditional approach of connecting sensors has generally made use of just a VPN. But now by using an XMPP server, we can provide that in the cloud. And obviously we can connect our smart devices and connect various different applications through that broker. But then to expand it to meet the scale, this is where you've heard the term federated systems. And interconnection of those servers in the cloud allows that to happen easily. So if you were to utilize systems like Amazon, Google now has such systems, Salesforce.com, there's a number of federated systems where you could potentially host your servers and provide a particular access system. Next slide, please. What I wanted to show you in this diagram is that we are technology agnostic. So anything really that has reachability to the broker, which would also have connection to the provisioning server, is all you need. I mean, you could be on any wired, wireless connection, satellite, whatever, and you'll be able to access that information. We want to make that as easy as possible. And next slide. And we see the IoT paradigm going to the local area network as well, because XMPP can be handled within the local area network, and it's firewall friendly, so it can communicate to the internet and pass information. Again, that mutual trust of the information is very important. You know, today in many industrial plants, they want to keep people out. So they may lock down the complete system, and by corporate policy, they may not even want anyone to access the internet. But yet there's a need where people want to communicate from their local area network within a plant and get that information out to provide alerts when certain things have happened, notification for potentially refilling, we'll say tanks that are on site, providing environmental monitoring information. I could go down a list of number of things that I could see coming from the local area network that we still want to share on the internet. Next slide. I'm going to go over this real quickly, which are the abstract services. Next slide. I mentioned this earlier about the gateway, which you can see from the left that in our standard, we define that those requests and replies, which are going over an IP network. And then you would have, in this scenario, we would have an XMPP capability that is connected to a service bus. So if your service bus resides, we'll say, in a gateway or connected to a gateway, for example, like Zigbee or Z-Wave or something that has an access point. It may even be connected to a Wi-Fi device using 802.11. You're communicating to whatever sensors that are connected to that device. So an adapter can be added to the gateway, collecting that information, converting it to XMPP, and now you have all those sensors connected so that you can share it. Next slide. And again, nowadays we're wanting to tie more and more sensors directly into the cloud, and we still have all those issues of security, interoperability to deal with. But you know, with all the systems that we're making today in form of chips, FPLAs, et cetera, you could probably embed a lot of that information right into a small chip with the IO subsystem. And being able to deploy that once again is just a matter of adding that abstraction with a direct connection to your IO subsystem. Next slide. This is a very important element, which I'm going to touch on in more depth here as we go further, and that's the idea of using a concentrator. XMPP has a XEP extension for being able to provide concentration of various sensors. So if you're collecting information, for example, from an OPC UA server, and take that information, which was maybe collecting data from Modbus, Profinet, or other field devices, and you want to share that information to the cloud. You can do that by connecting your OPC UA database, for example, which is connecting to the physical interfaces, and then adding this XMPP capability. And there are some products now available to do that that can share XMPP via the standard. Next slide. I'm going to just be breezing through this because I don't want to bore everybody with it, but I want to show you a couple of the key elements that you can look at, and I believe you can learn this very quickly. What I have here is the basic message structure, and hopefully you can see this on your screens so that as you look at the messaging below, you'll have a better understanding what it is. So notice it looks a lot like what you would have put in an email almost. But if you see the one that says XMINS equals, that particular command string, which you build in, is calling to the library of the XMPP EPs. You don't have to write that code. You just have to add the information that's requested for that XEP. Now go to the next slide. Okay. Obviously, a very important element for the censored systems that we have to have a way that the sensor can discover the server. And this is the message that does that. And you can see where it initiates a query, sending out a string, and then it asks, you have interoperability capability, which means do you have that library that is for interoperability. And of course, sensor data allows you to read sensors. Control would allow you to output something to an actuator. And a concentrator is another one I just mentioned. And these can all be asked in a query because we basically have a dialogue now that can occur between the device and the server. And during this initial request, he's going to find out, well, if you have all this capability, then we'll go forward. If you don't, you're denied. You'll be denied for a lot of reasons. If you haven't registered your device, and so on and so forth. Next slide. And this is a simple response because we're not doing polling. We have this exchange of requests and replies. It happens very quickly. But again, we're looking for something that let us know, was that request accepted in this case. Next slide. And again, interoperability takes two forms, which I'm going to talk about here. Because we're riding on the 21451 standard, as I said earlier, and I mentioned about the TEDS, the Transducer Electronic Data Sheet. We had to address something that I'm going to show you. Because those legacy systems used XML, there's been changes, obviously, over the last 15 years. But again, we have to try and find a way to deal with that. And I'm going to tell you how we did it. In this particular message, we're just asking for what kind of interfaces you have if you were to do that. Move forward to the next slide. And here it comes back and lists all the types of interfaces that are supported. And of course, you can add to this list. This is just a partial list. And you might be using this for some embedded devices. Next slide. This is the slide I just added that addresses that problem I said earlier. Because some legacy systems like 21451 originally used XML, it has its own constructs, which were essentially in binary in many cases. So we needed to translate that into a structure that would be compatible with the interoperability XEP. And we use something called XSLT, which is a W3C standard. And you get a structure of commands that allow you to read that information and get it into the same form. Next slide. And that's why I verbalized earlier. But again, the most important element is to gain conformance with the latest W3C standard, as well as to have it maintainable in the future structured way. Because the initial XML may have not had that kind of structure. And that would have been problems, particularly with today's browsers, which do meet the standards for W3C. We don't want to run into some issues. Next slide. And I actually spoke about this a little earlier, but I'll just reiterate it a bit. But that provisioning capability is basically to register your thing, if you will. We actually call it a thing server. And that can be for a user, or a device, or an application. So again, we use the JID, which when you go to register your device, you can obtain the JID. And the owner has to claim that device, I said earlier, and that you can see your device then in what's called a thing list, which is a list of those registered devices that you own, as well as you can eventually see what others have shared with you. And obviously you, as the end user, have the capability to make changes, as well as remove that thing from service. We're not relying upon someone in the middle to do that or have access to that information. I think that's a very important element. Mutual trust is assured by agreement to share that data. So this is a really, really important element. Next slide. This is some simple commands that show you how that request and reply was set up. You'll see where it says is friend XMINS. That particular command is calling the provision XEP, and it's forwarding a JID, and that's about what it takes. And you're able to provision your device. We're trying to keep this as simple as possible, and I think that is doing that. You're seeing what the request and the result is. Next slide. Another XEP that's very important is called sensor data. That's one which you will use to read various devices in your network. And it basically abstracts all the information about that device. So when you would have provisioned that device, you would have already supplied a lot of that information that said what its engineering units and so on and so forth. So we're not having to remember any of that. And the again, this is an attempt to keep things very simple and be able to pass just the actual data that we need. And I said, see it here, simple. You know, the simplicity is utmost importance, and because we're looking at dealing with literally millions of devices in the Internet of Things. And today, when we would do such things for provisioning access to information, we, in many cases, don't actually even send a tag name. We may just send a data slot from a register, if we were using Modbus, for example. The endpoint has to remember what the tag is for that information and the description of that information. That information has to be shared with other people. And there's a lot of things that have to happen. And even though we have some very large systems today, they don't necessarily hit the scale of millions. We may see maybe tens of thousands on some very large systems that we see in refineries and so on. But compared to what we're expecting from the Internet of Things, we had to have something that was could handle that scale. Next slide. Again, this is just a brief messaging that shows you the request reply, where again you're using that XMINS command and calling for a particular request from a sensor that you've provided, and then you'll get a response. This is, I've accepted that request. Next slide. The actual data, when it responds from a message reply, it may have the actual data. It will have possibly the time of day that the information was collected, as well as maybe GPS coordinates of where it was located, so on and so forth. Next slide. IO control is one that's used for talking to actuators. And that's another important element for the Internet of Things, because invariably there may be applications where we do want to provide some kind of signaling that would turn something on or off. And I find this is a very important element, because today there really is nothing to prevent it from happening. If you've seen some systems that are working today without any kind of security or policy or any way of preventing that information from being sent into a system, my feeling is that it could do some very serious damage, and it's very unsafe. So having that mechanism in place that we spoke about earlier in the provisioning of the system, we can define what we can safely do with actuation. Next slide. And this is what the command is. As you can see, they're not very complex. I mean, very simple to, from your command request and reply. And even though this is maybe a little bigger than a small packet that would have been in binary, you're getting a lot of other capability in that process. Next slide. This is one of the ones that I spoke about earlier that was very important, is that idea of concentrator, where you can connect up your XMPP adapter to something like a PLC, for example, which might be collecting, information from a small set of sensors. Or you may move up to a more medium scale, which is connected to various islands of information on your network, which are coming from possibly dedicated sensor devices, instruments, or other PLCs, or even a DCS system for that matter. And that information then can be sent via XMPP. But then addressing that large scale type systems, again, that's another important element where you see it in things like smart grid and Internet of Things, where we need that scale to address. Concentrators can do that. And by the way, concentrators are the way that we are addressing translation of legacy device protocols, where by writing the code to translate from, for something like 61850, which I'll talk about a little further later, you'll be able to transport that via XMPP. Next slide. I just got this one in the other day because someone asked the question, says, well, how can I update the information on the registry? And again, there's a simple command to do that. And but there is two differences. One would be for a singular type of device, or next slide, please. You may want to update something that's in a concentrator. Again, you'll see the structure looks very similar, other than that little command in the middle that has some additional attributes for its source ID and node ID. Next slide. What we're trying to do with XMPP, though, is to provide a way of harmonizing various censored systems. We aren't trying to replace other systems that people have, whether it's MQTT, COAP, REST, OPC-UA type systems. We want to work with everyone, but facilitate that data exchange in a secure, safe way. And XMPP, XEP concentrator and XEP interoperability provide that assurance that the endpoints can interoperate with the data they provide, and include the engineering units of data and whatever logic state information. And of course, you can share that data with various databases and so on, and you can perform your data analytics. Interesting enough, having participated in a number of NIST working groups, which I've been on the Cyber Physical Systems Working Group, Big Data Working Group, Data Analytics Working Group, and most recently the Data Forensics Working Group. These are all excellent activities, but they have a common problem in being able to share the actual data and then to perform that information analytics. You have to move all that information to some server somewhere where the data analytics can be performed. And I won't go into all the details of how it's done today, but it's very centralized, needless to say. It's not really a decentralized kind of system. And massive security concerns, obviously. Next slide. I wanted to introduce you to one other new capability that we've introduced, and that's a new URI, which is called a Uniform Resource Identifier, where you'll now be able to add HTTPX. So if you wanted to set up a session where you're going to send HTML, you can do that by, again, registering your site or service that's using a web service, and then send that through a web server, which would then have it encoded, but we signal that through the URI. So we're trying to make it very easy that people will be able to leverage the use of Semantic Web and still utilize Web 2.0 web service capabilities. Next slide. And this was a little more about what's called efficient XML interchange, which just was a new compression capability that was added, and so we can do it right in the stream. Today, we would have probably used various compression engines like zip, for example, to do this offline, where we were transferring a file or whatever, or collected all the sensor information and then compressed it and then send it in a file. We want to do that right in the stream, so that when you transmit your data and you specify the EXI option, when you do your initial discovery from your sensor or from your system, you can ask it to set up a compression capability via EXI. And again, this is defined by the W3C in XEP 0322. Next slide. What you're seeing in these constructs is the use of compression, as well as how you set up your security session. You'll see here in the stream, we can specify a start TLS, for example. That one string there, when it's sent to your server, you're basically asking the server, I want to set up a TLS session. It didn't have to be done by a separate software. And adding the compression capability is an optional thing, but again, you have to send the server a message and say, well, I want you to use, for example, the zlib, which is used for zip capabilities. And the data in the message would be arriving that way. Next slide. Okay, I'm going to move on to one of the topics called software-defined smart grid.
Yeah, William, at this point, what I'd like to do is stop and get these questions answered before you move into this next section. There are some very good questions that have come on since you've been presenting. I will just read them and you can answer them quickly.
Okay, thank you.
All right, so the first one is from Michael Shea, who asks, would using a service broker create a single point of failure potentially?
I would say that if you were not using more than one server, then that could potentially happen. Because again, it is an intermediate server.
Okay, next question from Javed Akram says, why XMPP versus Socket IO?
You have to forgive me, I'm not familiar with Socket IO.
Okay, so one thing, William, that would be very helpful for the industry is to put these various protocols and the impact that they have on the network resources, memory processing, bandwidth, so that people can make an apples-to-apples comparison. One of the things I'm finding increasingly is everyone claims what they've got is lightweight and some other group claims it's heavy. And it just doesn't work unless there is a quantitative comparison between the various protocols for the same kind of activity.
Sure.
So because the next comment Javed has is, he says XMPP is very heavyweight and it is a legacy code. So what would you like to say in response to that?
Well, it's not actually code. This is request and reply. So the actual code can be implemented in C. It can be implemented in the new languages, whether it be Java, JavaScript, so on and so forth. So as far as the actual coding, it can be whatever you like. But the standard is to send the data in a particular way. And that's what's being addressed here. People have considered it to be heavy because in the past that might have been an issue when you were sending over relatively slow speed networks. Strange as it may seem, we have a lot of bandwidth today, and being able to send things is a lot easier. And being able to do what we're doing right now was virtually impossible, as much as even 5 to 10 years ago. So what might have appeared very heavy in the past to send video, for example, is done very easily today with new versions of MPEG-4, for example, and being able to send these types of constructs, I believe, can be done very rapidly. You probably would hardly even notice it. In the past, I agree, we would have had these kind of issues because of bandwidth constraints, speeds of the processors, memory, so on and so forth. But nowadays, I just saw some in the news, I can get 2 terabytes of hard drive for $59. Or I can buy a complete computer for about $10 and yet still have broadband capability. So I think the paradigm has to be thought about differently nowadays.
And the next question from Javed Akram says, what percent of end user devices today support XMPP?
I'd probably say virtually everything, because XMPP exists in all major operating systems. A couple of the XMPP servers like OpenFire and Tegeese are ones which have integrated in the new IoT XEPs. And I believe that even almost all smartphones, as well as like iPhone, as well as Android and others, their operating systems have supported XMPP for quite some time. And as I said earlier, it's actually a capability that you're using every day and probably never realized it was there.
And Bob Lefebvre of PG&E asks, how is XMPP either supporting or actively preventing government access to message channels or other aspects of XMPP communications?
Well, again, as I said earlier, you as the end user have to give permission for that. If the actual government doesn't have access to the flows through an XMPP server, and if you wanted to grant information to be provided, for example, to EPA or some other government agency, well, then you would have to grant them access to that particular device. And I know one of my customers here near me, they want to do such things like that, where they want to share certain environmental information with the EPA for state compliance. And they have to be able to then have that kind of access to that particular instrument. Again, you as the owner have to decide that you're going to do that. That's not been necessarily so easy to do before, or probably was avoided altogether.
And that was partly because there was a bifurcation of the application from the security controls, which XMPP is embedding in the service itself.
That's correct.
All right. Next question, Bob Lefebvre says, what provisions and analyses have been done on wireless network loads of IoT devices? Will new spectrum bands be needed? I
guess I'm going to answer it this way, because there are some needs to have new spectrums when you think of wireless. In fact, I didn't put it in this presentation, but we are doing some work now to use VLH, very high frequency, which only has a bandwidth of 10 kilohertz to 20 kilohertz, versus we talk megahertz of bandwidth required in the gigahertz spectrums. We also have a huge amount of bandwidth that's been released from the television systems that were shut down some years ago. Those original bandwidths were 6 megahertz. Well, you can break that up into much smaller segments that the FCC has been very slow about releasing. But again, being able to provide sensor type data, particularly for the Internet of Things, I think, is going to be very beneficial if they release some of that spectrum. And I did learn recently, by the way, Irfan, that it is possible to obtain a commercial license where you can provision a particular service in these spectrums, which were previously held by commercial television, for example. And then you can provide your particular service. And you literally will get many miles of coverage from a relatively low power transmitter. Again, these are all on the radio side. The actual messaging that you can do can be done with a effectively like a chat message. I won't go into a lot of details, but we are working on something like that right now, where spectrum allocations are changing, but a lot of people like the FCC are still waiting for industry to step and say, we have the need to have that kind of capability. Can you provision that spectrum? So today, what we see is Wi-Fi, and of course we see cellular. And there's always a lot of competition for cellular type systems. But for a lot of applications which are more critical, I believe, which we've been using these technologies, they are used by many other services. So as I have noticed, when they have been used, by the way, for use in disasters like first responders and so on, many of those systems do go down. They lose power very quickly, or the towers go out. So having some way where we can do that more reliably is going to be needed. So I think, to answer the question, we probably will eventually need other spectrums to use for wireless, but they won't necessarily be in the gigahertz spectrum unless that happens. But the only area I have seen it has been in vehicle-to-vehicle. The Department of Transportation just mandated this for in all new cars to have collision avoidance systems that will be provisioned in the 5.9 gigahertz spectrum, I believe. Again, that is substantially above the 5 gigahertz spectrum. Anyway, that's a long answer to the question.
Yeah, I think the important thing to understand is that today wireless networks with different bandwidths are being used for different applications. And there may be situations in a low power mesh network where the XMPP running over it without a guarantee of throughput could be delayed, and it can cause problems. So it's very important before you decide to put any new protocol on a network is to come up with proper use cases and know in the transactions what kind of response time you're going to entertain. And if you can't meet that response time on the network that you have, then you don't put that protocol on it. And so that's why the baselining and capacity planning is so important. But you can't blame the protocol, because the protocol has a trade-off between giving a little more verbosity so that you can get more detail versus being more austere and having limited functionality. So XMPP is trying to hit the middle ground, if you may, between being too verbose, like a common information model type message, or being too austere, like a very simple Modbus kind of messaging. So XMPP is falling somewhere in between those two. And it's important to understand that and size for it correctly. Okay, let's move on. The next question is, again, are sensors vulnerable to denial of service attacks, man-in-the-middle, or address spoofing?
Actually, a lot less, because of the provisioning through the service broker and the way that it operates. Man-in-the-middle attacks are a lot less probable, and I guess the endpoints and stuff. Yeah, go ahead.
I think it's important to understand what man-in-the-middle type attack would be, because the fact that XMPP requests authentication from endpoints and only gives allowances for certain entities to see it and not others, man-in-the-middle type attack would usually be of a disruptive nature rather than one of stealing information. So they could easily put in a jammer on a frequency, but if you're using frequency hopping, then that may be a mitigation around that. So it makes it much harder. If you have a man-in-the-middle type attack where you can actually take the packet, change it, and then reinsert it in the stream, then that's a problem. But the way XMPP is set up, with the endpoints being the brokers, it's very difficult for that type of man-in-the-middle type attack.
Right, and by the way, it really doesn't matter whether you're IPv4 or IPv6, because, again, we're concentrating on the use of the JIT as the identifier.
Yeah, I think a key thing to understand the distinction is what this XMPP server is. A lot of people are getting confused and thinking it's some kind of repository, and if people got in there, they'll steal the family jewels. It's really an application layer router more than anything else.
Oh, exactly.
Yeah.
Why don't we continue with this next one, because I think it's going to answer a couple of the points that you just made on software defined.
Let me take this last question here and then give you some time to go ahead and finish your presentation, but because a lot of people cannot stay the whole hour and a half, and I wanted to make sure their questions got it right. So next is, what do you think about XMPP versus file-based for real-time data exchange?
That's versus what? Sorry?
File-based.
File-based.
F-I-L-E-B-A-S-E, yeah, file-based.
Once again, that's another one I'm not familiar with.
Okay, well, we're going to have these questions for later, so you can do some research and get back to them on it. Okay, next question is, would using a service broker create, yeah, we did that question. And then Javed had a couple of questions. And then Michael Holdman says, I would like to speak, if I may. I'm a colleague of William in the IEEE and also am part of XSF. But the challenge with that is I don't know which of the caller he is. So what I'm going to do is at this point, unmute both of them and see which one it is. So, Michael, if you are on the phone, you can speak.
Yeah, hello, everybody. How are you today?
Okay, great. Go ahead.
Wonderful. So I just wanted to answer a couple of the questions that came out that I heard. First of all, if I could address the heavyweight issue that seems to pop up with XMPP. I think the best way that this has been described kind of simply is a gentleman, Holger Reinhardt, who's a chief architect at CA, on the layer 7 side, states that a protocol like MQTT or AMQP, a very lightweight protocol, is you consider that one blank sheet of paper, whereas with XMPP you look at that as a book, completed book. The weight of the protocol, and by the way, there's servers out there that can do 240,000 concurrent connections and 60,000 messages a second, as well as clients that can get down with a full TLS library to 89K flash and about 40K RAM. Without the TLS library, goes smaller, about 30K flash, and it also does not have the and that's also not optimized. When it comes to the weight of it, you have to understand that you don't have a lot of the external additions of applications and such that you need into your infrastructure. It is the security is included. And by the way, on the man-in-the-middle attacks, the way that those are mitigated is because of the fact that SASL SHA-1 Plus is actually a part of the protocol itself. So it allows you to channel bind. You put a certificate on both the device or the gateway and the server, channel bind, so if somebody does try to spoof the server, it can't, because there's confirmed certificates on both sides. That drops, and then it'll create a new channel if somebody does come in and try to do that. That's one of the reasons, as well as others, that the Department of Defense of the United States in 2010 mandated XMPP as the protocol for real-time communication. And that is to do voice, video, chat, and then messaging in presence. Messaging in presence is where M2M, M2H is included within that. In regards to the number of devices that are out there, XMPP is on every single Android device in the world. It is on all iOS devices. Every single app, all the app notifications you get in your iOS devices are done through XMPP server that Apple manages. It is, as I stated, it's mandated for the DoD. It is Bosch uses it for all their gateway to M2M devices, and I am also, along with IEEE and XSF, I am part of the UPnP, and we're currently I'm on the task force for both the cloud and the IoT, and we just standardized XMPP for the cloud protocol. Allseen Alliance, which is part of the Linux Foundation and it's got all joined by Qualcomm, has also determined XMPP to be the gateway to cloud protocol. To William's point, we work very well with all other protocols. We absolutely believe that there's space for each protocol within IoT. There's not going to be a holy grail or one ring to rule them all, as many of our competitors or brethren protocol geeks out there would like to think. It's the protocol to carry your traffic safely and efficiently over the internet, and that's specifically what it's for. As far as a central point of failure, you can have, it's a distributed system. So yes, you can have, but there's active-active clustering, there's global load balancing within these systems. So if you do lose one specific server or even one specific data center, that traffic will then be logged in on other servers. So those are just some of the things I wanted to add to this conversation. And along with, there's also one other group with its Technical Committee 57 in the IEC that is actually standardizing XMPP currently for energy. And that's being headed in the U.S. by Scott Newman from UISOL.
Very
and
good.
That's all I've got for right now.
That was Michael Holtman from Coversant Inc. Thank you, Michael.
You're very welcome.
Get back now to the rest of the presentation. We have about 15 minutes, so since we got most of the questions out of the way, I'm hoping for a pretty smooth last 15 minutes. So go ahead, William, and I will continue moving your slides for you.
Okay. Again, I want to thank Michael for his comments. What I'm going to be talking about here is the use of SDN in smart grid. And there's many areas, as you can see, within smart grid where we need to have control of the latency as well as quality of service. And today that's still done with a lot of dedicated connections. But again, a lot of the clouds you see here, which are coming from various homes, buildings, and massive amounts of new devices that we're adding to the grid, is going to add more complexity. Let's go on the next slide. Thanks. These are some of the use case areas. I'm sure we could think of a lot more, but the massive collection of sensor data that we're trying to do right now from many new sensors we're trying to add to the network. And of course, trying to perform big data, data fusion, and data analytics is going to draw upon that information. Of course, nationwide monitoring of buildings, homes, vehicles, and other structures is all part of the Internet of Things. And of course, first responders I mentioned earlier about receiving alerts, providing information during times of disaster or public emergencies. This is also stresses the networks when we need to have them available. Next slide. Okay, the SDN though is basically something new that not everybody's aware of. I think it's probably the hottest topic that's going on in the market right now, but it's decoupling the control and forwarding logic for the network infrastructure. And this is going to allow the network's behavior to be programmable from an application. So for example, whenever a sensor might enter a network and it communicates with an application, it may signal then the server then to provide information to the routers that will direct the data flow to be an optimal path. And whenever we've had that happen, we see a major increase in performance. And you're seeing this in systems across the internet today. Whenever they've provided SDN capability, there's been a huge jump in performance, and quality of service is much better. Next slide. And of course, XMPP, believe it or not, is used today. If you were to look at the architecture of the Juniper networks, for example, with their control product, it makes use of XMPP to set up the security session. As I said earlier, many people have used XMPP for that capability, but then they would make use of other protocols to forward command information via, for example, OpenFlow or Open Daylight is also used for commanding the routers. And they may use other protocols like IFMAP, I mentioned earlier, which uses the SOAP protocol, as well as the REST protocols to provide, command signaling. But again, they still are moving away from use of SSL and integrating XMPP, which uses the TLS transport layer security session. And TLS can make use of certificates which are required for smart grid applications. But this programmability then can be built into the cloud, where once the censored systems, as they said, contact a particular application, the application then can tell, well, I need to have a route set up for these types of sensors and maintained, and of course provide the other capabilities like Michael alluded to, should there be any kind of failure. So that those systems will be much more redundant, reliable, sorry. Today, SDNs are found mostly in data centers, but we haven't seen them move out to the edge of the network just yet. But there is a lot of work being done in this area. Next slide. I did mention this earlier, that software-defined smart grid will make use of either X509 certificates, tokens, and use mutual trust, as we talked about earlier, so that if they are collecting sensors from systems that are used for critical infrastructure, they can obtain the kind of level they expect. And I'm going to show you in a moment some diagrams that show this, of how XMPP now can be used with the new IoT XEPs to provide the command and control of various routers. And we have some work that's being done right now to build this into flow controllers so that you'll have dynamic routing available to provide that QoS and latency requirements that were mentioned. Of course, what we want to see happen here is providing a more intelligent, dynamic flow control for those data that are moving throughout the networks, particularly since there will be changing network conditions, and utilizing this in applications which require the mobility of that information, again, will also be needed. Even though we have some very robust systems out there, obviously we still want to see if we can do a lot better. Next slide. This is kind of the overview diagram, which here you're seeing that many of the linkages are using XMPP with semantics. And of course, they would still use provisioning servers to provide that information. But now, in addition to handling the actual sensor component, it can also signal to routers and provide a package to them that will set up the routes. That's what software-defined networks is trying to achieve. Next slide. Just in summary about what I've talked about on XMPP, other than I got a few more slides after this, it's already been mentioned how it is technology agnostic and protocol independent. We're using transport layer security, which also, as well as being firewall friendly, so that makes things a lot easier. And using metadata isolation, as well as a service broker. And having this capability of a single sign-on is achieved using our provisioning servers, so we can utilize established mutual trust. And of course, I mentioned about using efficient XML interchange. Next slide. Just to look forward again, what are we looking at as our transition of the power grid? And of course, today we see on the left are more centralized systems. But as we're moving toward a more decentralized power grid, which consists of many new renewable types of systems, the dynamics is going to change. We're going to have a lot more communications needed to provide the signaling information. I think we've only seen the tip of the iceberg of what is really going to be needed. Next slide. Obviously, a lot of people have been looking at use of microgrid. And here we have to have that close relationship of what's happening in the home or a building to allow our microgrids then to make decisions. And of course, providing signaling from all the various things in the home or in a building or whatever that we're going to monitor will all be feeding upwards toward our microgrid architecture. Next slide. And of course, you saw earlier that UPnP is now adopting use of the IoT XEPs, and so that will allow it to be used in many home appliances, for example, or using XMPP to communicate the systems today that are used for solar, wind, and other alternative energy systems can all be achieved. And next slide. I'm going to cover a few of the things we've achieved this year that I thought were noteworthy. One was the Smart America Challenge, which was directed by President Obama, and we did a presentation at the Washington Convention Center of our initial work. Next slide. And I did want to mention that in the work that we did, we had systems that are now deployed in Sweden, which there's probably over 5,000 homes or more that are utilizing XMPP, as well as it's now been adopted as the national standard in Sweden. If you go to the next slide. This was our unified communications architecture, which we demonstrated during Smart America. And here you see where major telco provider TeliaSonera is now deploying XMPP for use in their coverage area. That's going to probably provide XMPP to probably several million consumers that they have in their area. Next slide. And this was kind of all the people that participated in our Smart America Challenge from various systems, including ones here in the U.S. as well as in Canada. Next slide. The next one that we're working on, this is called the Global City Team Challenge. We'll do a similar activity in June of 2015. And the National Institute of Standards has partnered with a group called the US Ignite to help out in this activity. But you know, they've also teamed with the Department of Transportation as well as NSF and many others, so that we can further this activity. It's kind of Smart America Challenge Round 2. Next slide. And I'll make this announcement here that we now are offering IPDX.net, which will provide a collaborative research network environment. So if you happen to be with a major university or a company who would like to participate, and we welcome you to join our work with the Global City Challenge, and you're able to you know, try out XMPP. And for the various universities, we've offered this ability where you can call in and use the system for basically for free, you know, during the challenge. And then I think that's going to help out a lot. There's a website there at IPDX.net, which you can read a little more about that. Next slide. And I thank you very much for listening to all this. I appreciate that I covered a lot of detail in the beginning, since many of you probably had never seen some of the constructs of the XMPP IoT XEPs that we've been working on. And I appreciate your attention to that. And I'll take any other further questions in the last few minutes.
Yeah, so for those questions, I would suggest that because of the shortness of time, that you go ahead and email them directly to William, and the email address is right there, mact-usa@att.net. So please go ahead and direct your questions to William directly. I wanted to ask you a couple of questions about activities in harmonization with the object models of Smart Energy Profile, Common Information Model, DNP, and 61850 in order for people in the smart grid field to have less heartburn over the introduction of a new language at the application layer. So, William, what's going on in terms of creating that harmonization so that the XMPP can act as that neutral information model bed in which everything else can be mapped into?
Well, obviously, we've done some work here with using things like Modbus and tying in Zigbee and so on and so forth. There's some research work now with tie-in of 61850. We're not changing any of those things that are already existing. For some people like DNP3 community, you can't even get it certified to do anything different than what they specify in their standard. So anyone who makes a interface has to comply with whatever is being done from SGIP or any other group within Smart Grid. But I believe we'll have to introduce a lot more information for people to realize what are the benefits in the area of cybersecurity, for example, interoperability, and so on. Because a lot of this is very new in attacking some core issues that have restrained the use of many things that we need to get done for Smart Grid.
Yes. So the way I'm seeing this is the way I saw X.25 networks as IP came in. And, for a while they coexisted and there were adapters, and eventually the X.25 went away and IP became native all the way to the end devices. I see XMPP that way. While in the industrial sector it seems to be widely used, but a lot of the devices on the power system side may be enabled with XMPP, but are not really using it for doing the control on devices that are on traditional electric infrastructure. And with the Zigbee Alliance and what they've been doing with the Smart Energy Profile, there is a whole other domain there in the residential sector. So my recommendation is that if there were a set of adapters that could convert from SIM 61850, DNP, and Zigbee Smart Energy Profile into an XMPP format, then that could be used to move it across the wide area network to the devices that it needs to talk to. And another mapping could occur back on the other side. And eventually, as new generation of products come, they could be native with XMPP. What do you think about that, William?
Oh, actually, that's what we're encouraging people to work on. Whether you're a manufacturer, whether you are a researcher at a university, we're encouraging people to do just that. And
okay, because that's very important. One of the challenges for the economic decision makers, whether they be at utilities or aggregators or these new community microgrid programs, is this plethora of standards and object models, and there are different levels or layers of the OSI model that are involved in each protocol. That's why I went out of my way to keep talking about XMPP as a layer 7 provision and not to be confused with network layer or the physical or MaCT layer. A lot of protocols like DNP will go across multiple layers. So we have a mixed bag out there, and that's why interoperability has been a real challenge. And I've only seen Internet of Things largely working in commercials on television, high-paid commercials at that. And these are the barriers, if you may. So I like what you've done with the challenge, Smart Challenge America project, and at least beginning to show clusters of devices that will work together using this service. I'm not calling it a protocol, I'm calling it a service.
Well, that's correct. In fact, when we did have our presentation at the Washington Convention Center, I believe we probably were one of the only ones that showed that capability because that was one of the directives that we want. They wanted the various verticals to be able to share information. And that basically, if you were to ask anyone, they would have said, well, we're still working on that. So that is something that I believe that our standard and XMPP is now demonstrating that we can achieve that. So as I said, we're encouraging people to participate, and we'd love to have you join our activity, and you'll be able to have access and be joined with other people who share like interests and concerns.
I have Jeff Mulligan. He's trying to get my attention from the audience. Jeff, do you want to put a comment, or are you on the phone? If you could put a comment in the chat window, I could read it to William, because you raised your hand, but I don't know how to get you to speak because you're not on the phone. So I don't know what that is regarding, but I will wait just for a moment while I announce the follow-up to this. So for those of you who are still online, we have reached the end of our presentation. A copy, a PDF format, will be sent to all of you in the next day or so. And all the previous webcast recordings, including the presentations for the last 3 years, are now available on gridstarcenter.org, which is the Penn State GridStar project website. And the nice thing is that they have, I see Jeff he's come on. Jeff, are you on the call? I saw him momentarily, and then I don't see him now. Oh, there we go. Yes, let me unmute you. Okay, Jeff, go ahead.
Hey, I just wanted to thank William for this. It was a great presentation, and I did want to add that their participation, the XMPP participation in the White House Smart America project was beneficial. I did want to correct, we had 24 teams participating, and other folks absolutely did show interoperability between a couple of various protocols. Maybe not to the extent that William and his team were doing with XMPP. And not to diminish what they did, but I did want to clarify that both in transactive energy, smart emergency response, and a couple of others, we did have multiple, and that was the point of this, was to show how devices from lots of different vendors could interact. And so XMPP was one of those that did it. But this is a great presentation. Thanks, William.
Yeah, and to Jeff's point, we are not suggesting that the solution to all things is XMPP. We're just saying that we want to leverage an existing install base of so much XMPP compliant stuff. William mentioned every Android is XMPP enabled. So the question is, why reinvent the wheel? If there is already a large install base, let's leverage it. But if there are other protocols that have specific services that different stakeholder groups want to use, there's no harm in doing that, as long as there are very clear rules by which data will be exchanged at the touch points with other protocols. That's what we're going to eventually see.
And Irfan, just one other comment. As chairman of the IPSO Alliance, right, that's exactly what we're advocating. We're not saying that there is one and only one set of protocols that can be used to build the IoT, though we are very much bigots about all of these, and it's beautiful to see XMPP based on IP, because we do think that that is the common factor across all of these. And it's heartening to see folks like Zigbee finally get around to adopting IP. The folks at Thread making, their stuff is 6LoWPAN IP based. OIC has said it will be IP based, and even all the IIC Industrial Internet Consortium and also Allseen all have adopted an IP based solution, of which XMPP can certainly play a part in all of that. So I think it's great.
Yeah, I think that the IP bridge was crossed once people understood that this protocol in the middle of the OSI stack allows you to separate the underlying hardware technology from the applications, and this modular approach avoids obsolescence. So you can move from one application to another and not worry about the underlying hardware technology. And the other one that it does, the benefit that IP brings, is that it doesn't force the source and the destination to be physically connected in the same administrative network. it gives you a routing capability that allows you to go through multiple hops to get to your destination. So for those reasons, people cross the bridge and IP has become the de facto standard in the middle layer. But in the application layer, we are going to see different flavors because people believe in different services being supported. And it will be kind of like the laptop is today that has the HDMI interface. It also has USB, it has wireless, and it has the RCA connection. So you have all of these options available, and yet it all works seamlessly with the laptops that you're using. So we are not suggesting by any means that there'll only be one standard. We're just saying leverage the install base as much as possible, standardize your points where the different protocols or services will exchange data so that you can do a real network systems management that follows the ISO standard of fault, configuration, accounting, performance, security. You got to do all of that, and you cannot do that if you have a bunch of heterogeneous networks that don't have visibility into each other. It's very difficult. We're seeing that with renewable energy today, with wind farms and solar farms, that if the only connection is a logical connection at the lowest layers, it's not possible to understand how much capacity you have coming out of the wind farm and actively controlling it, throttling it down, to meet that just-in-time network. So we're seeing that with Internet of Things also. The more visibility devices have, the more granular control you have, the better you'll be able to respond to changing energy situations. So with that, I'd like to thank William for a wonderful presentation. I want to thank the audience for asking very nice questions, and to Jeff Mulligan and Michael Holden for their comments. Our next webinar/seminar is going to come out of Underwriters Laboratories in December. I'm going to be announcing the next speaker, so we'll have a session over there before the holidays. So at this point, I'm going to end the recording, and I will be sending all of these, the presentation and recording within the next day or so. So you all have a wonderful afternoon, and thank you very much.